All right, so on 1.7, let's go ahead and do some extra problems here. So we're supposed to solve the equation. So if you remember, if we took an x and we divided it by the 8, how did we undo that? Well, that meant we had to multiply by 8. So if we had divided initially, if we multiply by that same value on that side, those cancel and we get x back. But what we do on one side, we also have to do on the other to have an equivalent equation. So those 8's cancel, we get x. 6 times 8, well, that's 48. And so that says our solution should be 48. Well, that says if we do our check, we're going to take 8 into 48 because it's 48 divided by 8. And so 8 times what? Well, 6. Well, that'd give us 48. Subtract that 0. And that's what we said our answer should be. So that does check. Okay. All right, on this one it says, well, here we have 2x equals 0. And here we had 2 times x. So if we had multiply here, that means we have to divide to undo that, which means we have to divide to undo that. So 2 divided by 2, that gives us x. 0 divided by 2, well, that's just 0. Nothing divided by any number other than 0 is going to be just 0. So that's our solution. Now, does that make sense? Well, 2 times 0, well, that's going to be 0, and that's equal to 0. So that does check as well. Okay. Now we have another one again, and we had to multiply first. We had 3 times x is equal to 15. So we had a multiplication. So to get rid of the multiplication, we have to divide. So when we divide, those go away. We get x. 15 divided by 3. Well, if we need to, we can rewrite that. It doesn't hurt to get in practice on doing that. So 3 times what is 15? Well, 3 times 5 will give us 15, and we subtract that, that's 0. So that says x is equal to 5. Now our check, that just says 3 times 5 is supposed to be 15. Well, 3 times 5 is 15, so it does work. All right, so the next one, we initially divided by 5 our x. So if we divided x by 5 initially, to get rid of that divide, we have to multiply by 5. And if we multiply that by 5, we have to multiply the other side by 5 to get equivalent equations. So that 5 cancels that 5. We have x equals, well, 4 times 5, that's going to be 20. And so we're saying our x in this case should be 20. And do we check that? Well, we take 5 into 20. Well, if we say that's 4, 5 times 4 is 20. Subtract that 0. We say the 4, that's what it was. So that really is the correct solution to this problem. Okay. All right, some more application or word problems here. So it says when an unknown number is divided by 8, the result is 3. Find the unknown number. All right, so we're looking for unknown number again. So let's call it n just because. Okay, so when we have an unknown number and it's divided by, so we're dividing that unknown number by 8. So n divided by 8. The result is, so the result is, and the result is what? Well, that's just equal to 3. Okay, so we've written our equation from the words given and coming up with our own definition of what the variable is. The variable is n is equal to the unknown number. So if we took n and we divided it by 8 initially, and we want to get n back, what we have to do is multiply by 8, because that multiplication is going to cancel there, and we just get our n. But if we multiply by 8 on one side, we have to multiply by 8 on the other side as well to keep equivalent equations. And so 3 times 8 is going to give us 24. And so that should be the solution. And so the unknown number is 24. And so that would be how we write it out. Now we do our check. And so if we go an unknown number, so we say 24 is divided by 8, the result is 3. Does that check out? Well, 8 into 24, well, that's going to be a 3. That's 24. Subtract, that's 0. And so it does check out. Okay, here's another one. This one is times them. So it says 5 times an unknown number is 35. Find the unknown number. So again, we have an unknown number. Let's call it x this time. Again, doesn't matter what you label it as. It could be anything as long as you don't put a number there. So we're going to say 5 times the unknown number x. So 5 times x is 35. And so we've just rewritten this sentence into this equation. 5 times some unknown number is 35. Now, if we multiplied the letter x by 5, to get rid of that, we have to divide by 5. And when we do it on one side, we do it on the other side as well. So that 5 cancels, and we get x equals, now 5 goes into 35. Well, 5 times 7 is 35, and so our solution then is 7. So this time, the unknown number is 7. Now again, we're going to check it to make sure. Does 5 times 7 equal 35? Well, 5 times 7 is 35, so it does check. All right, so here we have another rectangle. So let's go ahead and draw what a rectangle looks like and label what we know. We know the length and we know the width. So now let's read what it asks for. It says the area of a rectangle is 77 square feet. If the length of the rectangle is 7 feet, find the width of the rectangle. Well, we're looking for this time the width, so we'll call just width W. And it says the length is 7 feet. And it says the area is 77 feet squared. Okay. Well, again, what did we know about area of a rectangle? Was just length times width. So now we just plug in what we know. Area is 77, length is 7, so 77 equals 7 times W. And now we have our equation that we have to actually solve. And so if we look at our variable W, well, it's multiplied here, so to get rid of that multiplication, we have to do a division. And so those cancel. On the right, we get W, and now we take 7 into 77. Well, 7 goes into that 7 one time, that's 7. So we get 0. Now we bring down another 7. 7 goes in there one time also. That's 7. Subtract, we get 0. So it looks like 11 feet is going to be our width. Okay. Now, does that make sense? Well, it says 77 is supposed to be equal to 7 times 11. Well, 7 times 11 is 77. And so that does check out. And so our check works. And so we can say the width is 11 feet. And we don't want to cross everything out. We just want to for some reason, my pad's sideways. That's what it is. There we go. And so then we have our width is 11 feet. All right, so here we have the price of one computer is $490. A charitable organization purchases an unknown number of computers, and the total price of the purchase is $5,880. Find the number of computers purchased. Well, so what we're looking for is computers purchased. So let's call that X. And it says the price of one is $490. We don't know how many we're purchasing because if we take the price of each computer times the number we purchase, that should give us the purchase price. So we have the number, we have the cost, and then we have the total price. So we take the cost per computer times the number of computers gives us the total cost. Okay. So now what we have to do is think about what we need. Well, here we have a product, and so that means we have to divide by 490. Okay, so when we do that, that cancels. We get x equals, and now we have a long division. So 490 goes into 5880. Well, 490 doesn't go into 5 or 58, but it does go into 588. So let's subtract that. So 8 minus 0 is 8. 8 minus 9, well, guess what? We have to borrow here. So that's going to be a 4. That's going to be 18. 18 minus 9, well, that's 9. And now we can bring down our 0. Well, if we think about that, 490 times 2, that's going to give us 980. So that's a 2. That's 980. Subtract, that's 0. So we're going to have 12 computers. So we're going to say we bought 12 computers. And if you wanted to, you could say we bought 12 computers at $490 per computer for a total of $5,880. Or you can just say we bought 12 computers. Now, does that work? Well, if we take 490 times 12, then we have 2 times 0 is 0. 2 times 9 is 18. Carry 1. 2 times 4 is 8, plus 1 is 9. And then we have a 0, and then a 9, and a 4. Remember, that one doesn't count, that space. Now we add 0 and 0 is 0, 8 and 0 is 8, 9 and 9 is 18, carry 1, 4 and 1 is 5. That is the same as our total price, and so that does look to be the number of computers we did buy at $490 each. Okay, so that's all I have with this section.